everyone, it's Mr. C, and I'm back in the lab doing what I do best, making a mess. That's why I've partnered with D.E.F.I for this science video. Whether I'm using highlighters to dye my carnations, or making huge elephant toothpaste eruptions which stain nearly everything it touches, I use the D.E.F Beauty Bar to keep my hands clean, and most importantly, soft and moisturized. We need these thingies to be able to do science for many more years. My family and I use the D.E.F Beauty Bars all around the house, and I thought it would be fun to dig a little deeper to explore how a little bar like this has so much impressive cleaning power. See, D.E.F uses a technology called D.E.F.I, which stands for Directly Esterified Fatty Isethionate. That's a tongue twister, I know. But basically what it means is that D.E.F replaces the lipids in our skin instead of washing them away like traditional soap. The D.E.F Beauty Bar uses a syndet, or a synthetic detergent, to clean our hands. The molecules have two ends. A hydrophobic end, which is scared of the water, and it attaches itself to the dirt and grime, while the hydrophilic end attaches to the water. As these two work together, these surfactants are able to remove dirt from our hands.
Let's get out of here! Let's get out of here!
But the D.E.F Beauty Bar doesn't dry us out. This molecule is a surfactant and works to break the surface tension between the water and solids. I've got a demonstration to show us the effect this molecule has on water surface tension, but we're going to need some materials for this one. D.E.F Science! That's more like it. We've got our water, pepper, a plate, plus our D.E.F. And now we're going to pour some water onto the plate and let it settle. We're going to give it just a moment to settle so that when we sprinkle the pepper on it, it'll be nice and still. As you can see, when we sprinkle the pepper onto the water, it's floating on top of the water. That's because of surface tension. Water molecules hold on to each other. However, the water molecules at the top, they have an extra bond that they stretch out to the water molecule next to them. This makes the surface of the water a little stronger, and that's why the pepper is able to float. But if we put a little bit of water on our finger and then rub it onto this, and then place this right in the center, that is so awesome. The pepper glides away from the center of the plate because the surfactant is doing its job and breaking the surface tension. I love this experiment because it allows us to see that the molecules can help break the surface tension to clean our hands. That's what's really cool about the D.E.F Beauty Bar. This thing's awesome, and it's there to remove the dirt and the grime, but they don't strip away the moisture and oils from your skin the way that other more harsher surfactants like soap will do. Let's get this cleaned up so we can explore more. After cleaning up the pepper plates and doing a little more research, I also learned that D.E.F isn't a soap. Let me repeat. D.E.F is not a soap.
D.E.F is not a soap.
Soaps are a specific type of surfactant that are made from a chemical process. They can be harsher on our skin and typically have a pH of 9 to 11. And while soaps can clean and remove dirt and grime from our body, they also strip away the moisture and lipids skin naturally has as they do their work. You know that squeaky clean that you get after you use soap? Well, that's your body screaming at you saying, you stripped away the moisture and lipids. The great thing about D.E.F is that this beauty bar is not harsh on your skin at all. Human skin generally has a pH of 4.5 to 5.5, but what do you think the pH of this cleanser is? What do you think this D.E.F bar might be? Let's find out. D.E.F Science! Let's use some red cabbage and the anthocyanin pigment in it to determine whether something is acidic or basic. D.E.F is supposed to have a pH of 7, which would make it neutral. The combination of pH 7 and surfactant science makes it gentle on skin, meaning it won't irritate these delicate little hands as I wash them repeatedly while making messes. Doing science here in the lab. Let's get started. We're going to mix these things together in this blender, strain it, and then we can do our testing. It looks like a brain. Oh no. I made a mess. That's okay. We're gonna strain it, and the smell is wonderful. We'll get it cleaned up. Oy, oy, oy. I put too much liquid in there. All right, let's strain this. Oh, it's wicked. All right, here we go. So now we have our juice. We're gonna clean this up a little bit. We're all cleaned up. I've got the indicator ready, and now it's time to set up the cups. We've got lemon juice, baking soda, bleach, and we also need a solution for our Dove. So what I'm going to do for that is I'm actually going to wash my hands over here, and then I'm going to have all of the lather just seep into my cup right here. So let's get a good lather going. Oh, this is gonna work really well. It lathers up so easily. Look at this. And I'm gonna take that lather and put it right into this cup. And this is going to be lather for our test. Whoa. I don't want to splash into my juice at all. That would be so bad. All right, we got a great lather. There we go. Get a little bit more water so I can get this off. Oh, I missed the cup completely. But I think that is plenty of lather. I'm gonna add a little bit of water to that too, just so we have like a liquid to pour into our thing. So I need to clean those off. Fresh and so clean, and I'm not smelling the horrible red cabbage smell that is in this room. You have no idea. It smells so bad. But my hands are fresh and feeling moist. All right, let me dry my hands off really quickly. So my hands are dry and we're ready to test. We're gonna keep the center purple. We're not gonna add anything to it just so we can always see what the purple looks like. This is neutral. We have our lemon juice. We have some baking soda. We have the Dove Beauty Bar lather. And then we also have some bleach. So let's start with our bleach over here. See what it does. Whoa, that turned green instantly. All right, I didn't even have to stir it. Let's do baking soda next. Oh, that looks blue. So we have green and blue. All right, so it's changing, right? We'll leave that in there. Now we're gonna keep this neutral, and then we're going to, we're gonna pour that in. That is amazing. Oh, I don't have another spoon. That's okay. We're just gonna spin it like this. Do you notice anything? It actually didn't change color at all. That means that this has a pH of 7. It's neutral, just like this. So it didn't have any effect on our indicator. That is super cool. It's a little foamy because it's an amazing lather. And now we have our lemon juice. Pour that in. And it turns pink. That is awesome. So here we have something that's very acidic. We know that lemons are acidic. Here we have our neutral Dove Beauty Bar. That is so cool. Here we have our neutral indicator. They're exactly the same. This has a little bit of lather on top. This here is our baking soda, which is a blue, and then we have our bleach, which is green. Acidic to neutral to basic, all right? So, as you can see, our Dove Beauty Bar has a neutral pH. That is super cool. Wasn't that a super fun way to test this beauty bar? It's awesome. It has a pH of 7, and not only does it have a pH of 7, but it also smells really good because this cabbage juice is stinking up the room. It smells so bad. It really does. Well, there you have it. We had some fun doing science experiments today with the Dove Beauty Bar, and we learned a little bit about the science behind getting your hands clean and moisturized and smelling fresh. Thanks for hanging out with me today. It was so much fun. If you want to do science experiments like this, grab yourself a Dove Beauty Bar and compare it to other bars to see if they are as awesome and neutral as the bar that we just tested. Take care, have some fun, and we'll see you next time.